page 9. With section 3, this is where we're actually going to start calculating probabilities. So we're going to calculate probabilities to begin with where all the outcomes are equally likely. So a classic approach to probability. And then we're going to talk about the addition rule. So here are 4 properties that you have on page 9 that are really important. The first one says for any event, the probability of that event is between 0 and 1. So that should be common sense. If the probability of an event is 0, what does that mean? Not going to happen. It's not possible. What if the probability is equal to 1?
It's definitely going to happen.
Definitely going to happen. It's guaranteed. Second one, if S is the sample space, the probability of your sample space is 1. So for example, we talked about yesterday, if I roll a die, my sample space is 1, 2, 3, 4, 5, 6. The probability of rolling 1, 2, 3, 4, 5, 6 is 1. I can't roll anything else. Third one, if 2 events are disjoint, the probability of E or F, you just add them together. Can you underline that word disjoint? Because it's really, really, really important. The events have to be disjoint. The next section, the events are not going to be disjoint, and I'm going to change the formula on you. So when the events are disjoint and you're looking for an OR, you can just add them together. What if I'm looking for the and they're disjoint? Probability of E and F. What? Speak up. You're right.
0.
0. Yeah. Remember, disjoint means it can't happen at the same time. So probability of E and F is going to be 0 because it never happens. And then for any event, the probability of that event and its complement is 1. Together they make up the sample space. What's important from that is the probability of a complement is 1 minus the event itself. This is really, really, really helpful. A lot of times, the probability of the complement is really, really complicated to calculate. So instead, we choose to calculate the event itself and then just subtract from 1 because it makes our lives easier. Okay, questions on our 4 general properties? Okay, everything else that we're doing today relates to those 4 properties. So this now is on page 10. Okay, so we're doing the pick 3 lotto. We have 3 machines that contain balls numbered 0 to 9. What is the probability that you would match the first ball? 1 out of 10. You're right. What's the probability that you would match a 3-number sequence? So that if I pick the numbers 1, 2, 3, that the balls then come up 1, 2, 3. Okay. So this one we said was 1/10. What's the probability that I match the first ball? 1 out of 10. What's the probability that I match the second one? 1 out of 10. What's the probability that I match the third one? 1 out of 10. So then the probability that I match all 3 is 1 out of 1,000. There's one thing we're assuming here. What are we assuming?
They're fair.
Yes, that's true. Not what I was thinking of, but yes, we're assuming that all the balls are fair.
Every outcome is equally likely.
Yeah, that relates to all the balls are fair. No, we are assuming that. It has to be the same order.
After you get your replacement.
Yeah, after I pick the ball, I'm putting it back in. So it's possible to get 3, 3, 3, 4, 4, 4, etc. Okay, so that should be pretty intuitive. Here's the next one that we're doing. A researcher would like to randomly pick 2 of the 6 collar counties to study. Do you guys know what the collar counties are? No, me neither. I had to look it up. Okay. It is Cook, Kane, Will, DuPage, McHenry, and Lake County. So I'm randomly picking 2 of the 6 counties. List all of the possible combinations. So in other words, list the sample size. Do that now. I'm telling you order doesn't matter. So if I pick Cook and Kane, Kane and Cook, that's the same thing. So don't write them twice. Okay, I got 15 possible combinations. So you should have 15 also. Of course, if you were doing this with your homework, you would define what all those letters mean. So C stands for Cook County, K stands for Kane County, etc. Is each outcome equally likely? So is it equally likely that I choose Cook and Will as it is DuPage and Lake? I'm just picking names out of my hat. So I want you to assume that yes, they're all equally likely. What is the probability of each combination? 1 out of 15. Yeah, there's 15 of them, so the probability that I get any one of them is 1 out of 15. Okay, what is the probability that both counties selected are west of 294? Oh man, okay. I think this is 294? Is that look right?
So are you considering Lake west of 294?
So that's 294, right? Okay,
Is Cook County in there?
Cook County is not west of 294. Oh, so I guess Kenosha is okay. So we have Kenosha, Lake, DuPage, Will, McHenry, Cook. Okay, so what's the probability that both counties selected are west of 294? So that's any combination except the ones that involve Cook. Because it says both have to be west of 294. So we ignore those 5. So in those 5 possibilities, one of them is east of 294. So Cook County is east of 294. There are 10 left, so this probability would be 10 out of 15, which is 2/3. I prefer your probability to be expressed as a fraction if it's possible. You can convert it to a decimal if you want. Definitely do not tell me the probability is 67% though, because that is wrong. What's the probability that one county is west of 294?
How about 6?
Let me say it this way. What's the probability that at least one county is west of 294?
15 out of 15.
Yeah, just one. Cook is the only one that's east of 294. So in every possibility, there's at least one county that's west of 294. Okay. Okay so far? Yeah? Okay. Moving on. Okay, so I said each one was equally likely. I just put them all in a hat and I was drawing out one name at a time. Now I'm saying that the counties are weighted. Cook County gets 6 slips of paper. DuPage and Kane get 3, and the rest get 1. What is the probability that each is selected? How would I go about answering this? You guys should at least be able to figure out where to start. How should you start?
I'll add up the number of sheets of paper.
Yeah. Yeah, you're going to start by figuring out how many slips of paper am I putting in this hat. So I said Cook got 6, DuPage got 3, Kane got 3, Lake got 1, Will got 1, McHenry got 1. If you add them all up, there's 15 slips of paper total. Now, please know that this 15 is completely unrelated to the 15 from the previous problem. The previous problem, the sample space, the size was 15. This is unrelated to that 15. Okay, so then the probability of Cook gets 6 slips out of 15. So 6 out of 15 is 2/5. DuPage and Kane, they have 3 out of 15, which simplifies to 1/5. Kane is the same, 1/5. And then Lake is 1 out of 15. Will is 1 out of 15. McHenry is 1 out of 15. How can I check my answer to see that this makes sense? Add them all up. What should they all add up to? 1. I'm going to tell you they add up to 1. Okay, we got one more thing to do. Sound good? Okay, great. Last thing, you should be able to tell probabilities based off of a table. So LMS stands for large, medium, and small schools. And then the CDK, LMW, those stand for the counties. So the first probability that I'm looking for is the probability that if I choose a school at random, that it's in Cook County. Okay, so you just look at the Cook County part. So it's 0.59 plus 0.06. So 0.65. So the probability that if I randomly choose a school that it's in Cook County, that's 0.65. What does that mean practically to us? Because that's the first question on your homework, is something like interpret that probability.
There are 100 schools, approximately 65 of them would be in Cook County.
Yeah, out of 100 schools chosen at random, about 65 of them are going to be in Cook County. The way I would word it is, in the long run, when randomly choosing schools, 65% of the time the school chosen will be in Cook County. So that's the only time that I will permit you to use percent, is when you are interpreting probabilities. So again, in the long run, when choosing random schools, 65% of schools chosen will fall in Cook County. Okay, probability of choosing a medium-sized school. You're going to look at this right here. So you're going to add all those up. Please show me that that's what you did. Anytime that you have a question like this where you're reading off of a table, I consider this showing work. So I know that you know how to add, but you have to show me what numbers you added, and the AP test expects the same thing. One thing I forgot to say earlier, so I want to go back and make sure I say it. For this example that we did, what's the probability that both selected are west of 294? Just ignore that writing. You remember how we got the answer 10 out of 15 and we simplified it to 2/3? Okay, if you just write 2/3 and you don't write 10 over 15, you're not going to get full credit. From me or from the AP test. They expect to see the unsimplified fraction and then the simplified fraction as well. Can we make sure that we do that?
And we have to simplify afterwards?
For the AP test, I do not think so. For me, I would like you to simplify it, yes. Okay. So let's go back to our table. Okay. How would I do the probability of a school in Cook County or a medium-sized school? Let me say one question first, and then you two can answer. Can I do the probability of Cook, add the probability of medium? So can I just add the previous two problems? Or the previous two probabilities?
No,
No, why not?
because there's interlapping.
Yeah, they're not disjoint. So don't just add them. Instead, you're going to take Cook County, and then you need to add on the medium-sized schools that we didn't account for. So these schools, and then these medium-sized schools. Adding those all together, I'll just tell you, you get 0.75. Questions? No? Justin?
Wait, how did you get 0.75 again?
I added up these numbers and then these numbers. Okay, questions on sections 2 or 3 at all? No? Okay, here's what I'm thinking we're going to do right now. We are going to go over your test. Does that work?